Hello students, yesterday we have seen the first function of number theory, that is greatest integer function, and we have also seen some of the properties of it. Now here let's take some examples on it. So example, for what values of real number x, it is true that first greatest integer function of x plus greatest integer function of x equal to 2 times greatest integer function of 2 times x. Second, x plus half plus x minus half equal to greatest integer function of 2x. Third, x plus 3 equal to greatest integer function of x plus 3. Fourth, greatest integer function of 9x equal to 9 times greatest integer function of x. Fifth, greatest integer function of x plus 3 equal to greatest integer function of x plus 3. Now solution. First, let x belongs to R, therefore x is equal to n plus mu. 0 less equal mu less than 1 and n is in set of integer. So this gives greatest integer function of x equal to n. That gives greatest integer function of x plus greatest integer function of x is equal to 2n. Call it as equation number 1. Now 2x is equal to 2n plus 2 mu. Therefore, greatest integer function of 2x is equal to 2n plus 2 mu. Call it as equation number 2. Thus, greatest integer function of x plus greatest integer function of x is equal to greatest integer function of 2x. If and only if greatest integer function of 2 mu is equal to 0, that is 0 less equal 2 mu less than 1, that is 0 less equal mu less than what? Half. Thus greatest integer function of x plus greatest integer function of x is equal to greatest integer function of 2x is true for those real numbers x whose fractional part is less than what? Half. Now whose fractional part is less than what? Half. Now the next one, greatest integer function of x plus half will be what? It will be plus greatest integer function of x minus half. It is obviously greatest integer function of 2x, because if x is the fractional part of x is suppose greater than half, then here itself it will form 2x, but if here it will be greater than half, then here it will eliminate that, so here the term is less. Fine. Now the third part, let x is equal to n plus mu 0 less equal mu less than 1. Therefore, x plus 3 is equal to n plus 3 plus mu. 0 less equal mu less than 1. Therefore, x plus 3, greatest integer function of x plus 3 is how much? N plus 3. That is equal to greatest integer function of x plus 3. So that gives us the greatest integer function of x plus 3 is equal to greatest integer function of x plus 3. These are same. So let me eliminate this one. Okay, this one. Now let's take the next one. Fourth, let x is equal to n plus mu, 0 less equal mu less than 1 and n belongs to what? Z. Therefore, 9x is equal to 9n plus 9 mu. Therefore, greatest integer function of 9x is equal to 9n plus greatest integer function of 9 mu. If n equal to 1 and greatest integer function of 9 mu is equal to what? 0. That is n equal to 1 and 0 less equal 9 mu less than what? 1. That is n equal to 1 and 0 less equal mu less than 1 upon 9. Therefore, greatest integer function of 9x is equal to 9 times greatest integer function of x. If and only if x is equal to 1 plus mu, and what is mu? Mu is strictly less than what? 1 by 9. Greater than equal 0 but less than 1 by 9. Now, this is about this example. Let's take one theorem that gives the number of highest power of p such that p raised to alpha divides n factorial, and we will take examples of that kinds. Okay, theorem. This theorem is known as de Polignac theorem. De Polignac theorem. Now, what the theorem says, let m be any positive integer and p be any prime, then highest power E of p such that p raised to alpha divides n factorial is E equal to summation I from 1 to infinity greatest integer function of n upon p raised to I. Here p raised to I. P raised to I is that. Fine. Here be careful. This is P raised to I. Now let's take example for this example. Find the highest power of 5 which divides 1000 factorial. Which divides 1000 factorial. Solution. Let n equal to 1000 and p equal to what? 5. Then highest power e of 5 dividing 1000 factorial is e equal to summation I from 1 to infinity a greatest integer function of 1000 upon 5 raised to I. Here 1000 upon 5 raised to 1, that is 5, is equal to how much? 200. That is equal to 200. Okay. Now 1000 upon 5 square, that is equal to what? 200 upon what? 5. So it is 40. Next, that is 1000 upon 5 cube, that is 40 upon 5, that is equal to 8. Next, 1000 upon 5 raised to 4, that is 8 upon 5, that is equal to 1. Greatest integer function will be what? 1 here. Next, 1000 upon 5 raised to 5. 5 raised to 5. So it is 1 upon 5. That is what? 0. Therefore, what is E here? E is addition of all these. E is what? 200 plus 40 plus 8 plus 1 plus 0, that is 249. Thus 5 raised to 249 divides 1000 factorial, but 5 raised to 250 doesn't divide 1000 factorial. This is the, so highest power of 5 which divides 1000 factorial is how much? 249. Therefore, the highest power of 5 which divides 1000 factorial is 249. Okay. Now let's take the next example. Find the highest power of 7 which divides 1000 factorial. So solution, let n equal to 1000 and p equal to what? 7. Then highest power of 7 dividing 1000 factorial is E equal to summation I from 1 to infinity 1000 upon 7 raised to I. So here 1000 upon 7 equal to 142.66. So its greatest integer function is 142. Again 1000 upon 7 square. So it is 142 upon 7. So it is 20.66. So greatest integer function is 20. Again 1000 upon 7 cube. So it is 20 upon 7. So it is again 2 point something. So greatest integer function will be what? 2. Again 1000 upon 7 raised to 4. So it is 2 by 7. So it is 0 point something. So greatest integer function is 0. Therefore E is equal to 142 plus 20 plus 2 is equal to what? 164. Thus 7 raised to 164 divides 1000 factorial. But 7 raised to 165 doesn't divide 1000 factorial. That is the highest power, of 7 which divides 1000 factorial is 164. Next example, what is the highest power of 2, 3, 6, 12 dividing 533 factorial. So solution, first let n equal to 533 and p equal to 2. Therefore the highest power of 2 dividing 533 factorial is E equal to summation I from 1 to infinity 533 upon 2 raised to I. 2 raised to what? I. Okay. This. Now here this 533 upon 2, that is 2 raised to 1. So this is 266.5. So it is 266. Next 533 upon 2 square, that is 266 upon 2. So it is 133. 533 upon 2 cube, that is 133 upon 2. It is 66.5. So it is 66. 533 upon 2 raised to 4. So it is 66 by 2. So it is 33. Next, 533 upon 2 raised to 5, that is 33 by 2. So it is 16.5. That is, the integral part is what? 16. Next, 533 upon 2 raised to 6, that is 16 by 2. So it is 8. Next, 533 upon 2 raised to 7, that is 8 by 2, that is equal to what? 4. Next, 533 upon 2 raised to 8, that is 4 by 2, that is equal to 2. Next, 533 upon 2 raised to 9, that is 2 by 2, so it is 1. And next, obviously 0.5, so 0. So here we get, therefore E is equal to 266 plus 133 plus 66 plus 33 plus 16 plus 8 plus 4 plus 2 plus 1, that is equal to 529. Thus 2 raised to 529 divides 533 factorial, but 2 raised to 530 doesn't divide 533 factorial. So the highest power of 2 dividing 533 factorial is how much? 529. Therefore, the highest power of 2 dividing 533 factorial is 529. Okay. Now let's do the same for 3. Okay. Now this is a combined question I have taken. So let's do for 3. That will be the second part here. So 2, let n equal to 533 and p equal to what? 3. Therefore, by, you can mention that theorem also, D Polignac theorem, the highest power of 3 dividing 533 factorial is E equal to summation I from 1 to infinity 533 upon 3 raised to I. Okay. So here 533 upon 3. So it is 177.6. So it is 177. 533 upon 3 square. So it is 177 upon 3. So it is 59. Next, 533 upon 3 cube. That is 59 upon 3. It is 19.6. so it is 19. 533 upon 3 raised to 4, so it is 19 upon 3, so it is 6.3, that is 6. Next, 533 upon 3 raised to 5, so it is 6 by 3, so it is 2. 533 upon 3 raised to 6, so it is 2 by 3, so it is 0. Therefore, E equal to 177 plus 59 plus 19 plus 6 plus 2 plus 0. So it is 263. Thus, 3 raised to 263 divides 533 factorial, but 3 raised to 264 doesn't divide 533 factorial. Therefore, the highest power of 3 dividing 533 factorial is 263. Now next, let's do for 6. But 6 is not a prime, so before going towards finding the highest power of 6 dividing 533 factorial, let's write one result. Let's write down it as a note or a result. If m equal to m1 into m2 with the GCD of m1 m2 is equal to 1, and if E1 be the highest power of m1 dividing n factorial, and E2 be the highest power of m2 dividing n factorial, then highest power of m dividing n factorial is, that is, E equal to minimum of this E1 and E2. So let's do here this third one. 6 is not a prime, so 6 can be written as 2 into 3, and this 2 and 3 are relatively same of. Now the highest, just we have the highest power of dividing factorial is 529. Therefore, 1 is equal to what? 529. And the highest power of 3 dividing 33 factorial is 263. Therefore, E2 is equal to 263. Hence, the highest power of 6 dividing 533 factorial is E equal to minimum of E1 and E2, that is minimum of 529 and 263. So it is 263. Similarly, let's do for 12. So for 12 again one more result we can use. So let's write that result also. For 2 also the same result you can use, but for that you need to obtain 12 can be written as 4 into 3. So you need to obtain the highest power of 4 dividing 533 factorial first. Later on you can apply the same result. So without going for that result we can use other result also. Let's write that result. Okay. If m equal to p raised to 2 alpha, where p is prime and beta is the highest power of p dividing n factorial, then highest power of m dividing n factorial is E is equal to beta upon 2. So for finding 4 here, that's one we are doing. Let m equal to 12. Here this 12 can be written as 4 into 3, and 4 and 3 are relatively prime. If E1 be the highest power of 4 dividing 533 factorial, and E2 be the highest power of 3 dividing 533 factorial. Okay. Therefore, we get E2 is equal to 263. The question is left to find E1. Here, therefore, the highest power of 12 dividing 533 factorial is E equal to minimum of E1, E2. Okay. Here 4 is equal to 2 square. So 2 is a prime and we had written it in terms of prime raised to 2 alpha. There, this gives the highest power of and the highest power of 2 dividing highest power of that prime dividing n factorial we need to obtain. That will be our value of beta. highest power of 2 dividing 533 factorial is 529. Therefore, E1 is equal to, that is our what, beta here. E1 is equal to what? Beta by 2. That is the greatest integer function of beta by 2. That is 529 upon 2, and that is equal to 264. Therefore, E is equal to minimum of E1 E2, that is 264 and 263. That is 263. Thus, 12 raised to 263 divides 533 factorial, but 12 raised to 264 doesn't divide 533 factorial. That is the highest power of 12 dividing 533 factorial is 263. So here also we had used the greatest integer function to solve these problems. Now in next video we will solve one more example which is slightly different, and also we will see the next functions. Thank you.